Hello everyone. Today in this video we are going to discuss how to solve the system of non-homogeneous linear equations. Learning outcome: at the end of the session, students will be able to solve the system of non-homogeneous linear equations. Consider the first problem, test for consistency and if possible solve this system. Solution: first of all, we will write down the given system of equation in terms of matrix form, where this is what coefficient matrix A, it is the matrix of unknowns and it is the matrix of constants. Now for better row transformation, consider the augmented matrix AB. Now we will convert this system to echelon form. So first of all, I will consider the first diagonal entry and try to convert the elements lying below of that diagonal to 0 using this row number 1 only. So to convert this 2 to 0, we have to perform the transformation R2 minus 2R1. To convert this 3 to 0 using row number 1, we have to perform the transformation R3 minus 3R1. And to convert this last entry to 0, we have to perform the transformation R4 minus R1. Let us perform all these transformations one by one. In this augmented matrix AB, there is no change in the first row. Now performing this transformation R2 minus 2R1. To perform this, we'll multiply row number 1 by 2. Then the entries are looking like this. Now then taking the subtraction of this second row and this resultant row, we get 2 minus 2 as 0, minus 1, minus plus 2 is 1, 3 minus 2 is 1, 0 minus plus 2 is 2, 4 minus 2 is 2, 2 minus 2 is 0. Now performing the next transformation R3 minus 3R1, multiplying row number 1 by 3 and then now taking the subtraction, 3 minus 3 is 0, minus 2 minus plus 3 is 1, 2 minus 3 is minus 1, 1 minus plus 3 is 4, 1 minus 3 is minus 2 and 1 minus 3 is minus 2. Now performing this simple transformation R4 minus R1, 1 minus 1 is 0, 0 minus plus 1 is 1, 1 minus 1 is 0, 2 minus plus 1 is 3, 1 minus 1 is 0 and 0 minus 1 is minus 1. Now let us move towards the next diagonal entry and then try to convert the elements lying below of that diagonal to 0 using this row number 2 only. Now for that purpose, here the entries are 1, 1, so we have to perform very simple transformations like R3 minus R2 and R4 minus R2. The augmented matrix AB, in which the first 2 rows are as it is, as we are not performing any kind of a row transformation on these 2 rows. Now performing this first transformation R3 minus R2, let us see what we will get. Obviously these 2 entries are 0. Now the next entry, minus 1 could be minus 2, 4 minus 2 is 2, minus 2 is minus 4 and minus 2 minus 0 is minus 2. Now performing this transformation R4 minus R2. So yes, these 2 entries are 0. Next entry is 0 minus 1 is minus 1, 3 minus 2 is 1, 0 minus 2 is minus 2 and minus 1, 0 is minus 1. Now next, let us shift towards the next diagonal entry, which is minus 2. Then try to convert the elements lying below of that diagonal to 0. To convert this entry to 0 using this row number 3, will perform the row transformation 2 times R4 minus R3. Now the resultant augmented matrix will be, in which these first 3 rows are as it is. Now this row number 4 is going to change according to this transformation. When we multiply row number 4 by 2, we'll get all these entries. So we can see that both the rows are identical. So when we take the subtraction, the last row is reducing to 0. This is what the required echelon form. Now here we can see that In this coefficient matrix A, first three are the only non-zero rows. That's why I can say that rank of coefficient matrix A is 3. Now let us calculate rank of augmented matrix AB by considering the full system. In this also you can see that there were only 3 non-zero rows. That's why I can say that rank of augmented matrix AB is also 3. From these two we can say that rank of augmented matrix AB equal to rank of the coefficient matrix A. According to the condition of consistency, the given system is consistent. Here rank of coefficient matrix A is 3, number of unknowns is 5. We can easily see that R is strictly less than N. It means that the given system has infinitely many solutions. To find out that infinitely many solutions, we have to choose N minus R unknowns, means 5 minus 3, that is 2 unknowns out of 5 unknowns as the parameters. To choose that 2 unknowns out of 5 unknowns as the parameters, we have to write down the system of equations from this echelon form. First row will provide us one equation like this. The second row also provide one more equation, and this last row also provides one more equation. All the coefficients are in multiples of 2, so we can divide by 2. Then this third equation looks like this. Call it as equation number 3. Now from the last equation we choose 2 unknowns as the parameters. Now let us choose x4 as t1 parameter and x5 as t2 parameter. Now putting the values of x4 and x5 in this equation number 3, will get the value of x3, and that value of x3 could be 1 plus t1 minus 2 t2. Now putting the value of x3, x4 and x5 in this equation number 2, we will get the value of x2. And if we solve this for x2, x2 could be minus 1 minus 3 t1. And substituting the values of x2, x3, x4, x5 in this equation number 1, we will get this new equation, and solving this for x1, we'll get the value of x1 as minus 1 minus 3 t1 plus t2. So these are the required values of x1, x2, x3, x4 and x5. Let us consider one more problem. Test for consistency and solve, if possible, this system of equations. So first of all, writing given system of equations in terms of standard form A into x equal to b, like this, where A is this coefficient matrix, x is matrix of unknowns, b is matrix of constants. Considering its augmented matrix AB, now performing the row transformations to convert this augmented system to the echelon system. First of all, consider the first entry and try to convert these two entries to 0 using this row number 1. To convert this 2 to 0, we'll perform the transformation R2 minus 2R1. And to convert this 3 to 0, we perform the transformation R3 minus 3R1. In this augmented matrix, taking the first row as it is, now performing R2 minus 3R1 for row number 2. So when we multiply row number 1 by 2, we'll get all these entries. Now taking the subtraction, 2 minus 2 is 0, minus 1 minus 2 is minus 3, 2 minus minus plus 4 is 6, 2 minus 2 is 0, 6 minus 6 is 0 and 2 minus 2 is 0. Now performing this transformation, first of all multiplying row number 1 by 3 and then now taking this subtraction, 3 minus 3 is 0, 2 minus 3 minus 1, minus 4 minus minus plus 6 is 2, minus 3 is minus 6, minus 9 is minus 18 and 3 minus 3 is 0. Now let us consider the next diagonal entry and convert the elements lying below of that diagonal to 0 using this row number 2. So for that purpose, we can perform the transformation 3 times R3 minus R2. Augmented matrix AB will be, there is no change in the first 2 rows. Multiplying row number 3 by 3, we will get all these entries. Now taking subtraction, obviously first 2 entries are 0. Now it is 6 minus 6 is 0, minus 18 minus 0 is minus 18, minus 54 minus 0 is minus 54 and 0 minus 0 is 0. This is the required echelon form. Now let us calculate the rank of A. In this there were 3 non-zero rows are there. That's why I can say that rank of A is 3. And similarly, in this augmented matrix AB also there were 3 non-zero rows. That's why its rank is also 3. From this too we can say that rank of augmented matrix AB equal to rank of A. It means the given system is consistent, that is it has a solution. To find which kind of solution it has, so we have to compare R and N. Here R, that is rank of A, is 3, number of unknowns are 5. So we can say that R is strictly less than N. It means that the given system has infinitely many solutions. To find that infinite solution, we have to choose N minus R, that is 5 minus 3, that is 2 unknowns out of 5 unknowns as the parameters. To choose that 2 unknowns out of 5 as parameters, we have to write down the system of equations from this echelon form, and that system is we have written here. Now from this system, we have to assign 2 unknowns as the parameters. Mostly we are starting from the last equation, but in the last equation there were only 2 unknowns. So what we will use the trick, from the last equation we apply one unknown as the parameter, and to have one more unknown as a parameter, we'll select that equation number 2. Choosing x3 equal to t1 and x5 equal to t2. Now putting x3 as t1 in this equation number 2, it will give us the value of x2, and that x2 is 2t1. Now putting x5 as t2 in this last equation, that will give us the value of x4, and that value of x4 is minus 3t2. Putting the values of these unknowns x2, x3, x4, x5 in this equation number 1, will get the value of x1 as 1. So these are the required values of x1, x2 to x5, and it is the required infinite solution.